Good afternoon, this is Derek Smith, and this is my report on the CRJ Systems flight control surfaces, landing gear, and fire protection systems. Flight control surfaces, according to the reading in this week's assignment, the CRJ flight controls are hydraulically powered flight controls and are divided into primary flight controls, secondary flight controls, and the stall protection system. The primary flight controls are the ailerons, rudder, and elevator. The secondary flight controls consist of horizontal stabilizer, primary flight control trim systems, ground and flight spoilers, and high lift devices known as flaps. Flight spoilers. Spoilers on the CRJ provide aerodynamic, speed braking, and proportional lift. There is one spoiler on the upper surface of each of the wings. They are hydraulically actuated from hydraulic systems 1 and 2 and are electronically controlled. Spoiler Electronic Control Unit. The SCEU on the CRJ has 2 of these units that are installed in the avionics compartment. It is a dual-channel computer that monitors the movement of all flight controls and compares their position with the current airspeed. Spoilers are controlled by the pilot via a control lever inside of the cockpit. A green indication light will be seen on the ECAS status page when deployed. If the engine thrust were to be increased to 70% of N1 or greater, the pilots would receive an amber light with a caution on ECAS that the spoilers are deployed with a message to retract. Ground lift dumping system. On the CRJ, a GLD system is in place in the event of a rejected takeoff or could be used for normal landing operations. This system is used to increase drag and assist other braking systems in slowing the aircraft down. The GLD system includes the following: 2 spoilerons, 2 flight spoilers, 2 outboard ground spoilers, 2 inboard ground spoilers. The ground lift dumping system, GLD, can be armed automatically to deploy or manually. A 3-position switch is located in the cockpit that would allow the pilots to choose between auto, manually arm, or manually disarm the GLD system. If you've ever been on a flight and noticed by looking out at the wing upon landing and seen the spoilers come up during touchdown, this is most likely auto deployment of the GLD system, controlled by a proximity switch in the landing gear. The CRJ landing gear system. The landing gear system is comprised of the following components: 2 main landing gear assemblies, 1 nose gear assembly, nose wheel steering system, proximity sensing system, brakes, and anti-skid system. Landing gear and anti-skid are controlled from a central location on the pedestal between both pilots. Manual gear extension is located on the lower part of the pedestal between the pilots as well. Nose wheel steering is controlled through the rudder pedals and a tiller that is located on the captain's side of the cockpit. Landing gear and anti-skid. Landing gear indications. Extension and retraction are shown on the primary display. Brake temperature is shown on the status page, while brake pressure is shown on the hydraulic synoptic page. The proximity sensing system. The proximity sensing system consists of PSEU and sensors. PSEU is a double-channel system that receives inputs from a number of sensors throughout the aircraft. With this information, the PSEU controls the sequencing of the landing gear doors so that no binding or damage will or can occur. It also provides data to the pilots and monitors the status of all doors and the position of spoilers on the CRJ. The PSEU receives data from the following: from the thrust levers, flat position, cabin altitude, horn mute switch light, and landing gear lever. Extension and retraction of the landing gear. Landing gear extension and retraction are electronically controlled and monitored by the PSEU, and use Hydraulic System 3 for their power. Hydraulic System 2 is also used in the event of a backup system for emergency as an alternate to the landing gear system. Main landing gear components. The main landing gear components are as follows: main beam, axle-pneumatic shock strut, main gear actuator, trailing arm, hydraulic brake line, 2 main wheels. Nose landing gear consists of the following components: the shock strut, drag brace, actuator, dual steering actuators, uplock pin, dual torque lines, rear door attachment, and towing provisions in the event the aircraft would need towed on the line. Fire and overheat systems. Fire and overheat is divided into 2 main systems: fire and overheat detection and fire extinguishing. Detection and extinguishing systems. Fire detection system includes components which detect fire, overheat, or smoke conditions on the aircraft. Fire extinguishing systems include the containment and delivery of an agent in the event a fire is in the protected area. Detection system for engines, APU, jet pipe, and pylons consist of dual loop connected to common control unit to notify crew of a fire or overheat condition is present on the ECAS primary. All are dual loop except for the main landing gear, as they are single loop detection. There are also smoke detectors in the baggage compartment and in the lavatories on the CRJ aircraft. The following areas are equipped with fire detection and halon extinguishing systems: left and right engine bay, APU compartment, lavatory, and in the cargo bay. The main landing gear has detection only function and does not have an extinguishing function in the event of a main wheel fire. All of these items can be tested and monitored on the overhead panel in the CRJ cockpit. The CRJ regional jet, though smaller than legacy airlines, still requires much training and knowledge of its vast and somewhat complicated systems. We have gone over the very basics of fire detection, landing gear components, and the spoilers and their functions. But this jet has many more systems and subsystems not included in this report. As the saying goes, a good pilot is always learning, and with systems like these, I have no doubt the learning will always continue.